We need to talk about a couple of vocabulary words called domain and range. Domain is a word that means the set of all inputs, and range is the set of all outputs. And remember that our inputs are usually the x variable, if we're using x and y, or if we're using a different variable, we can choose that. And the range is our y variable, or the outputs are the y variable. So when we take a look at tables of values or different things, we're looking for our x and our y values to figure out what our domain and range are. So let's start with domain. We can often abbreviate that with a D. You will notice that we have our x values listed here. So our domain is just the collection of all those. -1, 0, 1, 2, and 3. We're going to write a list. Now, there is a notation called set notation, which tells you that all of these are a group or a set or a collection all together. It's this curvy bracket right here. And so we're going to enclose those using those curvy brackets. That means that this list is altogether the domain. Our range is the list of all of these. Now you'll notice that 2 happens several times. When we are writing down our domain and range, we don't have to repeat those. We just need to know that it's there. So we have our range is 2, 1, and 3. Typically, you write those in order from least to greatest. So I'm going to write those 1, 2, and 3, and I'm going to enclose them with the braces right there. And I don't need, again, to write the 2 multiple times. I just need to know that it's part of our domain. Okay, let's take a look at this graph, domain and range. Now our domain again is our set of all x values. So we have 1, 2, 3, 4 different points. The x values for those are -2, -1, 0, and +1. So -2, -1, 0, and +1. Enclose those in braces and we're done. Our range is the y values. So those would be 1, 0, -1, and -2 for this. So we'll start with our least. That would be -2, -1, 0, and +1. We enclose those again with braces, and we're finished with that. Now let's take a look at our last graph right here. You will notice that we have a curve going down and then back up. We need to know and understand that there are infinitely many points all along this curve. Any location on this curve has a point. And I cannot make a list of infinitely many things. So we are going to end up using our inequality notation to write down the area that works for our domain and for our range. So let's take a look at that. Remember, domain again is our x values. So our smallest x value happens over here on the far left side. That is +4. And our largest x value happens over here on the rightmost side, which is 13. This graph covers everything in between 4 and 13 right there. This is a compound inequality using the word and. So we're going to write the two inequalities. We go from 4 and increase, we go from 13 and we decrease. So our x values are greater than 4. This is a closed circle, so we get equal to 4 as well. This one is our x values are less than 13. Again, we have a closed circle, so we get to 13, so it could be equal to. And that is an and statement. So we can put these together. You could leave it like this, or you could write it as this. 4 is less than or equal to x, and that's less than or equal to 13. So that would be our domain. The range is our y values. So let's do the same thing with our y values, figure out what's the smallest y value and what's the largest y value, and then we will write it as an inequality like this. Well, our smallest y value happens right here. That is 6. Our largest y value happens up here. That is 17. And then this graph covers everything from 6 to 17. Now you'll notice that there are y values that are covered more than once. For example, 9 happens here and here, but I do not need to list this multiple times. I just need to write where does it cover. So our y values go all the way from 6 to 17. So our range is from 6, which is less than or equal to y, which is less than or equal to 17, because we have the closed circles when we get to 6 and 17. That's why I included the equals. And this is a similar interval like we had before that goes all the way from 6 up to 17. So we use this compound inequality that represents the connection of and. Thank you.